Hey guys, good morning all. Just give me yes in the chat if you guys can hear me and see the sublime text. Quickly give me yes in the chat if everybody can hear me loud and clear and you guys can see the sublime text. All of you can. Cool. I can see some of you are still to join. I can see 72 as of now. Some of you are still joining. Cool. We'll restrict to the first 10 minutes. Let everybody join and then we'll start with the session, which is almost here. All right, guys. As per my understanding, this is the first session that we are doing for high-level design course, which is yet to start from today. How many of you have taught before or how many of you have known me from before? Just give me yes or no in the chat. First time. Okay. I've taught some of you before. Some of you have not been taught before. It's fine. We'll go for a one round of introduction, then we'll continue with that. Okay. I'm just waiting for, okay, now we're at the 10 minutes mark. Now we can start with this. Those who have been taught by me before, you guys would know me from other batches. Either it's a DSA batch or a high level design or low level design or MERN or stack, whatever it is. Okay. Anyways, let's go for a quick round of introduction. I will first let you guys give your introduction and then I'll come to mine. Before I go there, considering we are a lot of people, it's not easy to interact with everyone. So this is what we'll restrict to. This is the very first class. I'll just make sure the basics are clear. We'll restrict to the chat. In case there's a particular question that you want to point out, please you can message to me directly. You can message to everyone. If it's a generic question, I would prefer message to everyone. So in case anybody else has same doubt, they can also clarify at the same time. Okay. If it's something very specific, something very personal, then you can just message to me directly. Zoom has provides the option for both. Okay. We cannot, unfortunately, I cannot provide the speaking access to everyone because it will become too hard to manage that and it will become problem for other people as well, right? But yeah, there are specific questions. You would have a mentor allocated, then you can come to that. If your mentor is not able to solve it, then you can take it to me. Okay. So there are two kind of point of contact, I would say, or three kind of point of contact as part of Tutort course. One is your mentor who will be responsible for your one-to-one attention, any kind of problems or something. If you're not assigned yet, in the due time you will be assigned to it. So don't worry if you don't have a mentor yet. Second is the instructor. I'm an instructor, so I'm responsible for the collective batch. In case there's a design problem, in case there's anything that you have not discussed collectively as a batch, I will take up that. Or in very rare case, when even the mentors are not able to solve your queries, then I will come up. Okay. And third is your course coordinator, which I believe is Astik. So you can directly get in contact with him in terms of your access or anything in general. He will be the first point of contact. He can answer your questions. Okay. That being said, guys, let's start with a brief round of introduction for you guys. I'll tell you what exactly I need from your end. Then I'll give my introduction and then we'll start with our today's session. Okay. I just need a couple of things. What is your current role / years of experience? How many years of experience? What are you currently doing? And if possible, one moment, guys, which branch you have done your graduation or post graduation, whatever the latest degree. Okay. I'll come to your question. First, let's go through the introduction, then I can come to your question. Go ahead, guys. The floor is open to you. You can message to everyone. Brief role, what currently you're doing, what's your years of experience, and that's it. Branch also does not matter, no matter where branch you come from. All right, front-end developer, 2.5 years. Nice. What about other folks? Architect, 20 plus. CTO at early UK-based startup, 7.5, SE3, .NET, 4 years. Backend, project lead, 11. Okay, cool. What else? 4.8, Java developer, front end, PHP, full stack, senior, junior, mainframe. Okay, that's new. Okay, 4+ years. I read it as 44 plus. It was 44, you edited it. All right, 7.5, 5.5. Cool. That's the number I'm looking at. 4, 8, 5, and 6. Okay. So I think the smallest I have seen was 2.5. Okay, there's a fresher as well. Okay. Cool. 2 years, 8 years, test automation. Good. All right, sounds good. Finish it up, guys. Then I'll continue with this. 14 years, full stack. Cool. More or less, that's what I needed from your end. So the reason I asked this question, I'll come to that as well. I have seen at least 2 to 20 years of experience. I think 21 was the highest I saw, somewhere around 22 to 21. And from 2 years of experience, we have various different people from dev, QA. I saw a few data scientists also, and some people working on mainframe tech as well, which is nice. Okay. The reason I ask this question is when I teach, I want to make sure that everybody understands. Since all of you are coming from very different backgrounds and very different frames in your career, it's important to teach in a way that all of you understand from the basic till the advanced level. If all of you were at the same level, it would have been easier. I would have directly start with the advanced part. But considering all of you are going in a different place in your career, so it will be easier to start from the basic, then we go to the advanced part. Okay. As of now, that's the only information that I need from your end. Okay. Couple of things. Once I cover at the end of the session today, I'll definitely ask for feedback. Feedback in terms of how fast I'm teaching and how slow I'm teaching. And if something that I need to teach faster, please feel free to let me know. We can adjust based upon it. Usually, whatever I teach, I'm going to repeat it. So in case anybody doesn't get for the first time, we'll do it. Another thing, this is the first session, so we don't have anything to revise. But from the second session itself, the first thing that we're going to do is we're going to revise what I've done in the previous session. Okay. All good, guys. That is something, the introduction at your end. Let me give introduction from my end as well, so you guys know who is your instructor and how long I've been teaching, so on and so forth. My name is Devang Sharma, which you would have probably seen in the Zoom chat already. Feel free to search on LinkedIn or just go to Google and you can search my name. If I talk about professional experience per se, let me come back here. I'm currently working with Amazon as a senior software. I am based out of Seattle at the moment. Prior to that, I worked with some hedge funds and other big tech companies. BMO being, I don't know if you guys know the full form of it. It's one of the biggest and oldest bank in Canada and US. I was a lead software engineer there, working for their hedge fund segment. Prior to that, I have worked with Meta, working on the WhatsApp business team. And prior to that, I worked with contract with Google and NASA. There I was a senior research fellow. Okay. That sort of brief of, and prior to that, when I just started with my career, I also worked with Grab and Cisco. Okay. That is about my professional experience. Coming back to my open source contribution, in case somebody is active in open source, I've been a very active developer to React and React Native, React 19 and React 61 native. If anybody is interested in it, you can see my pull request and my contribution in that, and Fedora projects. There used to be Google Summer of Code when once you're back in college, but since it has been a long time, I used to part in Google Summer of Code when I was in college. And last, I can talk about competitive programming. How many of you do competitive programming, or at least know about competitive programming? CP. Anybody? Okay. Few of you, those who don't know, it's completely fine. It's not something mandatory that you have to do, but if you do, it's really good. It's good for problem solving. So I took part in TCO, which is Top Coder Open. I have been 2021 and 22 world finalist. I didn't participate after that much. We'll see if I get time. I'll definitely participate next year. And there used to be a contest called Google Code Jam. I think they have discontinued from 2024, as per my knowledge. I didn't participate of 2023. So 2020 and 2021, I participated. There I was reached to semifinals, couldn't make it to finals. And Meta Hacker Cup, I think that is still continued. So you can participate in that when it happens for this year. I took part in 2020 semifinalist. And last, those who are interested in the research paper, you can just search my name on the ResearchGate. It's a very good website. Those who are interested about any kind of research paper, publishing or reading about it. I had around 600 citation. I don't remember exactly, but I'm pretty sure it's 500 something. More than 600 for sure. Yeah, guys, that's a bit, not a bit, that's a lot about me. I am the one who will be taking your design course. When I say design course, it's specific to high level design, right? There would be folks who will be continuing from the low level design, and there are folks who have already taught low level design. So two categories of folks: those who have already done low level design. This is the last part of your design, which is high level design. Those who are starting with high level design, you will continue with me for the low level design. Most likely, I'll be the one taking your low level design as well. Okay. Now, coming back to the syllabus, I'll talk about what is design in general, what are we going to learn about system design, what part of system design we are going to explore, what is high level design, what is low level design, all of those things. Okay. All right, guys, that's good so far. We got an introduction about each other. You know who's the one teaching you. I know the kind of audience I'm catering to. Okay. To your question, somebody asked, I do take multiple courses, DS and CP course. I do take MERN and MeanStack course, and Java Spring Boot course also I'll take. System design, I'm taking both LLD and HLD. Okay. To the question that somebody asked previously. All right, guys, I think we're good with the introduction unless anybody wants to add anything. If not, then we can start with system design. All good. Shall we start with system design? Cool. All right, guys, be a bit more active in the chat because I prefer the communication. Obviously, if I could, I would have given the permission to speak to all. But since chat is a mode of communication, be very active in the chat. Any question you want to message me directly or message to everyone, feel free to shoot it. Okay. Do not wait till the end of the session. If you have a doubt, feel free to just put the question in the chat. Okay. All right. Before we move to system design, let's have a very basic understanding. What exactly do we mean by system design? What is the definition of system design? When you hear the word system design, before you jump into HLD or LLD, even before you go into the details of nitty-gritties of that, the basic definition of, yeah, you will have the notes and everything. Don't worry about it. You'll get the recording, you'll get the notes. The basic understanding of system design is just how a software system is interacting with different components. That's it. That's what system design is. A software system, how it is interacting with different components. Now, when we say components, what do we mean? Components mean load balancers, client, server, database, cache, what else? Web servers, application servers, etc. etc. Okay. Anything which can be part of a component of a system, that's what we call as, that's how they communicate with each other. That's what we call as software design. Now, on an overview level, when we say design, it's categorized into two categories. One is called HLD and one is called LLD. I'll make sure each one of you have a very crystal clear understanding of what is a design, what is HLD, what is LLD, what are we covering as part of this particular course. Okay. HLD, as the name says, it is high level design. Okay. When you say high level design, what does that mean? The word itself says high level, means you're not going into the code, you're not going into the nitty-gritties, you're just considering on a high level. So it's an overview of different components of system, services, and how they interact with each other. That is what you refer to a high level design. So if I ask, take a problem statement, let's say, write me a high level design for WhatsApp. So what would be the high level design consist of? High level design would consist of a customer journey, starting from a sender, opening the WhatsApp application, sending a text to a receiver, receiving that, passing the read notifications, acknowledging that notification. How does that happens end to end? What are the components responsible? What is the load balancers or DB server cache? What kind of databases? What kind of services? What kind of notifications being used? What kind of polling mechanism is used? All of that comes under high level design. That's part one. Part two will be the scalability part of it. Because considering a scale of a product, for example, say WhatsApp, which has close to 3.8 billion total customers, active customers around 2.8 billion. How will you scale with the messages going into trillions of messages total by now? How would you scale it to that level? So all of these things, considering all of this scale and on those latency, how are we going to design a system like that? That is what we call as high level design. Okay. That is part one. Part two, which is low level design. LLD is your low level design. What do you mean by low level design? It includes UML diagrams, which basically includes four major diagrams: class diagrams, activity diagram, use case diagram, and sequence diagrams. These are the four critical UML diagrams that you need for any product. Okay. There are 23 UML diagrams, by the way, if we talk about the context of UML diagrams, but you don't need all 23. More or less, any kind of product that you build, these four are sufficient enough. Then design patterns, even before that, design principles and best practices, which include solid, keep it simple and short, do not repeat yourself, Yagnik, etc. etc. Okay. Design patterns, definitely. Design patterns, there are 23 design patterns which were given by Gang of Four. Really good design patterns, more or less, we're still using the same, which were built in 1995. And then on top of that, there is machine coding around. Okay. This is what your complete exhaustive list of design includes. Whenever you talk about design, either it can be referring to a high level design where you're talking about the overview of how the different components react. How do you make it scalable? How do you make it resilient? How do you make sure it's fault tolerance? What kind of databases, what kind of services, what kind of REST protocols, APIs, SSL connections, everything that will consider as part of high level design. Everything on the higher level. We don't talk about code, we don't talk about classes, we just talk about the higher level. Low level design specifically speak for the code level. What's the quality of code you should write? What's the design pattern you should use? How do you build a feature which is scalable, which is maintainable, all of those? What kind of design pattern you should specifically use for a particular use case? What kind of UML diagram you should build? What are the design practices? What are the best practices for writing code? All of those we discuss in a low level design. On overview level, both of these courses will take you around 10 to 12 classes. So we expect 10 to 12 classes. It can be more than that for high level design. And same goes for our low level design. Okay. I'm going to take a pause here and will make sure that everybody is crystal clear till so far. Any questions, any doubt, please ask. If you guys are clear, just type clear on the chat. Come on, guys, be quick in the chat. Okay. All right. Now let me answer a few questions that I got. I'm having 16 years of experience working in automotive software and system embedded domain. How can I relate this system design course while preparing for interview? How can I relate this system design course while preparing for interview? When you say relate, help me understand your question better. One moment, let me explain that. See, anything above mid-level engineer would definitely require your design course. So even if you are a fresher, I believe most of you already crossed the mid-level range. Even if you're a fresher, I would highly recommend start learning about design. And anything beyond the mid engineer would definitely require you how to learn about the system design. It's one of the, you will definitely have at least 1 or 2 rounds of interview. The more senior you'll get, the more rounds of design interviews you will get. Okay. So that's something, if you mean by relate, that's something definitely going to be asked in the interview. And if you mean by relate, how you can relate by the automation or embedded system in general, I'm pretty sure there are going to be similar things that you'll be connecting via different components. If you have a specific question, let me know. I can answer with that. But generally speaking, irrespective whatever interview will be appearing, more than I think, apart from the mid level, you will definitely have in design rounds. Okay. All right. Next question. What do we mean by machine coding round? Good question. See, machine coding round are taken by specific companies. I'm not say all companies do ask it. LLD, every major tech companies take. HLD, definitely every major tech companies take. In LLD, there can be different kinds of interview. They might directly ask you to about design principle or write some code or talk about low-level designs or best practices, so on and so forth. Or they can directly take a machine coding round. A good example of machine coding round is taken care by Flipkart, Walmart, um, Amazon also has it. And there is one more company, I think it's Uber. And there's one more company which is in India. I think it is called Delivery or DoorDash. Okay. They definitely have these kind of machine coding round. Swiggy also, by the way, Swiggy and Zomato. What are this machine coding round is? You will be given, these round will be from 2.5 to 3 hours. You will be given a problem statement. You have to write the complete feature for it, right? For example, it can be write me a parking lot problem. So you'll be given a certain set of parking lot questions and you have to solve that. So you have to come up with the entire code, all the functionalities, all the features. It will be a complete Google Doc which will be given to you and you have to implement all the functionalities of it, including mandatory and optional ones. Okay. That is what we mean by machine coding round. Examples of machine coding round, you can just Google, you can find some of the problem statement, you will find it here. As a prerequisite, do we need complete knowledge of tech inside HLD? For example, in and out of Docker or something, do we implementation experience of product or component? First part of the question, you don't need it. I would highly recommend if you have something that is going to help. What you need is at least the very basics, the understanding of computer networking and operating system and databases. That's it. Pretty much whatever you do in software engineering, it's built on these three. Know about the network protocols, know about how the protocols connect with each other, the 7 layers. How does the 7 layers interact? What are the OSI 7 layers, so on and so forth in networking. Databases, talking about the SQL versus NoSQL. I will anyways explain it, but if you have it or if you can read about it in advance, that is going to be helpful. And third part is the operating system. How does operating system connect, so on and so forth. Okay. LLD is language specific. No, LLD is not language specific. High level design, you're not writing any code. So there is no point of language here. For LLD, when you're writing the code, it is not language specific. You can code any language. Unless it's a role which requires a particular language, then it's exception. I'm working on building a product. Hopefully it will help in scaling a solution and scalable. That is correct. Should we complete LLD first and then HLD? No, it has no relation with each other. You can start with HLD, you can start with LLD, doesn't matter. Okay, both have different use cases. What are prerequisites? Already explained that. Object-oriented principles. Object-oriented principles comes under LLD. Okay. Here. Cool. All right, guys. That's in terms of understanding a very clear segregation between high-level design and low-level design. Okay. Now, where does this fit in the larger picture? Larger picture in the sense, I'm not teaching and I never teach in the intention of just clearing interviews. Interviews is one part of it. Over a period of time, you will become better and you will clear interviews. Obviously, the end goal, probably most of you, is just clear the interviews. But my end goal of teaching is not to help you in clear interviews. Yes, that's obviously part of it. But more important is becoming a better software engineer. So on that note, whatever that you will learn in terms of high level design or low level design, where is that going to help you in your software engineering? So when you talk about software development lifecycle, where does this part actually fits in SDLC? Your first part is requirements. Your second part is solution or design. When you say solution design, that's where it comes in. First, you start with the high level design, right? DB schema, all of those you will take care of here. Once you're done with that, that is when you'll move to LLD. So we'll talk about classes, interfaces, abstraction, what should be a service layer, what should be a controller layer, orchestration layer, etc., etc. All of those which is taken care in code, you will mention in 4. And then you will go for unit testing / integration testing. And then you will go for product release. That is how the design part completely fits into this, which is your software development lifecycle. Okay. All right, guys. Everybody clear so far? Having a clear understanding what is high level design, what is low level design, where does it fit in the SDLC? All good? Cool. If that is good, now we actually start with our high level design. We'll define what are the components we're talking about in high level design, and we'll learn them by one. High level design. So for high level design, the key characteristics of a distributed system. We'll discuss more about distributed system in CAP theorem, but in general, distributed system means the server nodes are distributed everywhere, right? It can be global, it can be in a particular local range. The nodes are responsible in multiple locations. That's what I mean by distributed systems. Okay. The key characteristics of a distributed system is here. I'll just take this part till the resilience. When you say I want a scalable system, when I want a distributed system, it should be scalable, it should be available, it should be consistent, it should take care of load balancing, it should take care of caching, data partitioning, CAP theorem. Choice of DB is a very important decision. It should be reliable, it should be efficient, it should be manageable, it should be resilient, right? Now, let's try to understand one by one what these terms exactly mean. What is the purpose of these terms? Okay, we'll start with one and then we'll go in sequence. Number one, when we say I want my system to be scalable or scalability is important for my system, what does that mean? I will let you guys answer. I'm giving you 30 seconds. Whatever your understanding, I don't need any Google answer or ChatGPT answer. Pure English, it can be just simple as 2, 3 words or whatever it is. Just in one line, explain me what do you understand by scalability of a system. Come on, guys, quick in the chat. Simple, plain English. What do you understand by scalability of a system? I don't want any rote language. I don't want anything bookish, Google search, ChatGPT search, anything. Okay, extend it to more functionality. Traffic increases, 0 to million. System can adapt new requirement. System can adapt new requirement. Okay. It should not fail if traffic increases, able to handle traffic. How much is the traffic? Number of user load increases, performance should be good. Okay. Last 5 seconds. Okay. Cool, guys. That's it. how it will work. Okay. Cool, guys. That's it. Enough time. I will not spend too much time on this. I'll definitely give you time to discuss more, but let's continue with this. Let's time box this activity to 30 seconds for whatever question that I'll tell you. If that requires more time, I'll give you more time. I got two categories of question, two categories of answer to this question, and obviously both cannot be correct. The second category, the first category is when the load increases, it should be able to handle. And the second category that I got is it should be able to handle more features, more functionalities. Is second one the correct answer? Is second one the correct answer? It should be able to handle more features, more functionalities. Those who have answered the second one, it is not the correct answer. What you are referring about is, which is not written here, but just to tell you, what you are explaining about is extensibility. Extensibility means how forward and backward compatible my product is, right? Means if I want to add more features to it, is it easy to add features to it? When I say easy, we have to take care of forward and backward compatibility. For example, if I'm building a SDK for my customers to consume, if I'm making some critical model changes, those will not be backward compatible. I will not call it as extensible code. Okay. But on the other hand, if I'm making a functionality on top of it and I can just update a new version of SDK, then I will call my product to be extensible. Okay. So scalability and extensibility are two different use cases. Okay. Now coming to scalability per se. What is the definition of scalability? In a very simple terms, scalability is the capability of a system, process, or a network to grow and manage increasing demands. That's it. Okay. As the word said, scalable means you get an increasing demands that can be due to multiple reasons. How is your system performing? Is your system capable enough to grow with the increasing demand and respond? It's not like if the demand increases, your system is stopped requesting or stop giving responses to that. Okay, that should not be the case. Your system is scalable enough that if your request increases, users increases, demand increases, anything in general increases, your servers are scalable enough that they can accommodate new requests and they can respond to it. Okay, without having any downtime. Now the question becomes, why do I need to scale in the first place? What are the scenarios where it can be scalable? Like if I'm having, let's say, consistent traffic, why is that I can have a spike in the traffic? Why I can have incremental spikes or decremental spike, whatever it is. See, for scaling, it can be due to multiple reasons. When you say increased demands, one thing is, which is really good for any product is you got increased users. You built an app, you built a product, that product was used by, let's say, 10,000 customers. And by the mouth of words, a lot of people start liking it. So the 10,000 become up to 100,000. That is when you will have increased users. Obviously, when the user will increase, the demand will increase, the number of requests will increase. Okay. Number two, due to increased request. So you did not increase the user, your customer base is still 10,000, but let's say you got a new feature in the product, right? And people are really liking that product. So that's why the number of requests that were responsible on your server, they have increased. Okay. And third is increased data load. That can be due to, again, multiple reasons. Let's say you built a new feature and that feature is customer facing and it includes some, let's say, photo or video upload. So when there's a file storage system upload, that is when you have a strong data load on your servers. Okay. So there can be multiple reasons which can contribute to increased demand. It can be either increased customer base, or it can be increased requests, or it can be increased data load. This part is still clear to all. What is scalability? Why do we need to scale? Come on, guys, quick in the chat. Okay. Once we are clear with why we need to scale and we are clear with what is the definition of scalability, now we'll talk about how part. Well, I usually cover this pattern, what, why, and how. It makes things easier. What was the definition? Why we talked about? Now we'll talk about how. Means ways to scale it. What are the different ways that I can actually scale my servers or scale my system? So there are two ways. One is called horizontal scaling and one is called vertical scaling. Let's talk both about one by one. Horizontal scaling, as the name says, Horizontally, you are going to scale it. Vertically means vertical, we are going to scale it. What does that horizontal or vertical means? Why they are termed like that? Let's understand. Horizontal means I'm going to scale by adding more servers into my pool of resources. It's much easier to scale dynamically by adding more machines. There is no downtime for it because I'm just technically just adding more machines. However, if you're adding more machines, that would require more cost. Think of an example. I have, let's say, X number of users or X number of traffic. I have two servers which are taking care of it. So these two servers are sufficient enough. They can give proper responses to the number of requests that I'm having. Now I got a load increase due to whatever reason. We talked about the three reasons which can have contribute to increased demand. I got a load increase. So what we need to do is, one way of doing that is I can spin up new instances. I can get new servers, S1, S2, S3, S4. Now what will happen? My request will be distributed. Load balancer will take care of that. Let's say I got 10,000 requests now. It was initially with 5K for S1 and S2. Now if I get 20K request, now it will become 5K for S1, S2, S3, S4. Okay. Assuming my server cannot handle requests more than 5K, if my 20K will increase, then I can have more servers. My more servers will take care of it. This part crystal clear to all. Horizontal scaling. Horizontal scaling means simply one thing. Whatever existing pool of resources, whatever kind of servers you have, you just pull out more machines into it. Okay. The reason it is called horizontal, one moment. The reason it is called horizontal is because you are horizontally adding more and more servers, right? You're not putting a server on top of a server. You're horizontally putting more and more resources in your pool. That is why it is called horizontal server. Okay. Server meaning database server. It can be any kind of server. It can be database server. It can be application server. It can be any sort of server. Okay. I have no experience with load balancer. I believe distribute the load geographically and load wise by definition. It does a bit of more thing than that. It has a inbuilt cache as well, but more or less your definition is correct. The purpose of a load balancer is to distribute the load equally. Nowadays, we have very smart load balancer. ELB is a very good example. Amazon has Elastic, AWS has Elastic load balancer. That's something that you can check out. It will dynamically detect which server has the capacity and will do it. So now in the introduction and implementation of AI tools, it can very predictably and optimize the traffic which is coming from to send to the location which is nearest to you to get the faster optimized time. Okay. Response time will be much reduced. We'll talk about in detail once we go to the load balancer, but more or less on a higher level, whatever you said is completely correct. Okay. All right, guys, coming back to this horizontal scaling, everybody clear? Just add more resources, which is definitely going to be costly, but we will not have downtime. This part clear? Come on, guys, be quick. Okay. Now, the second part is of the scaling is what we call as vertical scaling. Only benefit is downtime. I won't say only benefit. It's number one, it's easier to implement it because majority of the servers, majority of the databases that you will encounter, they're easily horizontally scalable. Not all of the databases are very easily vertically scalable. Okay. But majority of the databases are very easily horizontally scalable. Of course, there are exceptions, which we'll talk about in a bit. But in general, the examples of horizontal scaling or the purpose of horizontal scaling is number one, it's easier to do it. Number two, no downtime, which is important. And number three, majority of the databases support horizontal scaling. Okay. All right. Now, one moment. Server can handle 5K. No. Server can handle 64,000 requests. If I talk about a 64, okay, you need to understand something which I'll discuss more in detail once we go to server. A server usually has 65K ports. Okay. 2 raised to the power 32, whatever that number comes up to be, 2 raised to the power 8 to 2 raised to the power 10. So 65,236, that is the number of ports. If assuming that out of that 2 or 3,000 ports are used for internal purpose, then we keep all the ports empty. So more or less the server can respond to 60,000 requests. Okay. Current servers which I'm talking about. Okay. Of course, if you're talking about high capacity server, they can respond to more. But I'll discuss more once we go to a particular case design to talk about it. Can we descale as well dynamically? Yes, yes. Just like we have horizontal scaling, vertical scaling, we have something called downscaling. So there's a concept called auto scaling. All of this obviously will not manually do it. It will automatically happen. We'll have a trigger-based cron job. What will that cron job do? Whenever we are close to one moment, whenever we are close to 80% capacity, that 80% capacity will spin up a new instance. That's what you call as auto scaling. Similarly, when we realize that our system resources used less than 40%, then we can descale as well. So there is upscale, there is descale. Okay. 64K applicable for all OS? Yes. It's not OS dependent. Server is not OS dependent. Okay. But again, I'll discuss more in detail when we go for a case design specifically, then it will make more sense. When you say server, it's Nginx, Putty, Tomcat, something else. See, Tomcat is an inbuilt server that you get in the Spring Boot. Server can be, okay, server is a very generic word, right? Anything which is able to give you response, it's called a server. Whether it's coming from a database, it become database server. If it's coming from application, become application server. It's just coming from the web response, become web server. Okay. Server is a very generic word. Anything which serves a response is called server. Nginx, Putty, Tomcat, these are specific servers giving responses to frameworks. Okay. So in one quality, yes, they are servers, but here when we say server, it can refer to anything. Okay. All right, I've answered this for horizontal scaling. Now let's talk a bit about vertical scaling. What exactly do we mean by vertical scaling? And then I'll talk about auto scaling as well, since you guys have asked it. Vertical scaling means we are going to scale by adding more resources. Instead of resourcing, we call it as computational power. Computational power include adding more CPU, adding more storage, adding more RAM to an existing server. Okay. We are going to scale by adding more computational power, which includes adding more CPU, more layers of CPU, storage, RAM to an existing server. This is limited to capacity of a single server. Okay. And definitely will involve downtime because you are going to change the configuration of the existing machine. It has certain number of requests responding. If you're going to add something in it, you need to turn that off and then you have to do it. Advantage is cheaper because you are taking piece by piece. You are adding a CPU or a storage or a RAM at it, right? Instead of adding a complete machine, it's definitely cheaper than that. You might have seen this kind of things. Scheduled maintenance, something like this. Website will be down at, let's say, 1 a.m. to 3 a.m., something like this on, what's the date today? Let's say 27th April 2025. Have you seen this? Mostly on the bank websites, if you have carefully observed. Not always the bank website. I'm just giving an example. Like in general, the bank websites or any government website, you will see such kind of notification quite frequently. Okay. Why does that happen? Let's understand what they're trying to do. So first thing first, never obviously do a downtime at the peak hours. Every product would have its peak hours and non-peak hours, right? Think of an example of any product. Let's think of an example of Instagram, right? Instagram would have peak hours, although people are using it every time. Or, well, technically, Instagram is not a good example because people are using it all the time. So it's not a good example. But let's say take example of a bank. In case of a bank, people do transactions and they do transactions all the way. But if you generally speak, transactions mostly happen during the morning time, afternoon time, and evening time. Very rarely there are transactions happening. Of course, there would be. I'm not saying it's a zero traffic, but very rarely there will be transactions happening between 1 a.m. or 3 a.m. Okay. So you find that window that you need for actually downtime. You inform your customers in advance, and then you take care of this scaling part. This is mostly due to the vertical scaling. There might be other reasons. They might be changing configuration. They might be changing certificates. 100 other things can be done. Most of them are due to vertical scaling. Whenever they have to enhance more resources on the existing servers or the existing resources, by adding more computational power, that is what they call as vertical scaling. Okay. Cool, guys. Can we say vertical scaling is basically upscaling the infrastructure? Both of them is upscaling the infrastructure. It just depends what part of infrastructure. If you're getting a new machine altogether, that becomes horizontal. If you're adding more and more power to the existing machine, that is what you call as vertical scaling. But understand one thing, every machine would have certain capacity. So there's a limit that you can add storage to it. There's a limit you can add RAM to it. There's a limit you can add CPU to it. It's pretty much like this. If you guys go back like maybe 10 years from now, and I believe majority of you will still be able to relate it because majority of you are experienced. There used to be there not used to be as many laptops. There used to be CPUs, right? One moment, guys. When I say CPUs, I'm talking about monitors, then CPU, then speakers, and those things, right? Computers, basically. In those computers, there used to be RAM for 2 GB, 4 GB, 8 GB, 16 GB were not that popular at that time. Mostly it were 2 GB and 4 GB. 10 or 12 years from now, I'm talking about earlier 10 and 12 years from now, right? At that time, you might have, if you have played games, at least that's how I learned. That's how I learned about programming or in general. If you used to play games, you would realize the graphic card were not sufficient enough to actually load good graphics. Okay, one moment, guys. I'm coming to that. I'm trying to correlate with something which I want to explain in terms of vertical scaling. If you would have played games, really heavy games like God of War or something like GTA 5 or something, you would have realized if you try to run it on a 2 GB RAM, it is not able to load at all. Or even if it loads, there's a huge downtime in it. All of you can relate if I can take you 10 or 12 or 15 years back. Have you ever wondered what is happening? Why is that a 2 GB RAM is not able to accommodate whatever that thing is trying to do? You need a specific graphic card, and that graphic card will not even work on 2 GB. And if it does, it will become so slow, you will not be able to play anything. If you increase that 2 GB to 4 GB or the 2 GB to 8 GB, then the game will run very smoothly, right? What is happening? What is happening inside it? That graphic card, and used to be NVIDIA most of the times, but whatever that company's graphic card, it needs some processing memory. And that processing memory comes from where? The processing memory comes from RAM, because RAM is your primary memory. It needs some processing memory. When you increase from 2 GB to 4 GB or 2 GB to 8 GB, it got that memory. Once it got that memory, now it is able to execute its operation faster. At the end of the day, everything is a disk I/O operation, right? That disk I operation required some space, and that space was not able to accommodate in a 2 GB RAM, because 2 GB is your complete RAM. You have to take care of your all the applications you're running plus operating system, whatever space it is taking, right? That exactly what happens. So same logic in the vertical scaling. What you are doing is whatever terms of resources your particular server is serving, you just added more power to it, which will still take care of more conditions, but to a limit it you can do it. For example, in those CPUs, you can increase it up to 16 GB. You cannot make it 2 terabyte of 8 terabytes or something like that. Okay. That's the example of vertical scaling. This part clear to all? Application is down in vertical scaling because, okay, understand it. Understand from a gaming perspective that that analogy will help you understand. You're playing a game, your RAM is 2 GB, you have a graphic card, not working, very slow, lagging. Can you make its RAM increase from 2 GB to 4 GB without turning off the game or without turning off the computer? You cannot, right? Same logic here. Whatever your customer traffic, the same server is responding. So until unless you add more resources, how would you add more resources? By turning off the machine, and then you'll add more resources. Okay. And then you'll check everything is working fine, and then you'll turn back the traffic. That's how. Obviously, you'll take care of feature flags and all those things. I'm not denying that, but in general, that's how it will happen. Okay. All right, guys. Everything that I was saying, I was referring in context of monitors and laptops, nothing on the mobile operating system. Okay. So this is horizontal scaling, vertical scaling. That's what we discussed. And some example which I was discussing before. There are databases which are quite easily horizontally scalable, which includes Apache Cassandra, which is a very important database we'll talk about in a lot of case studies, or MongoDB. One moment. Majority of the NoSQL databases that you will encounter, they will get easily horizontally scalable. Vertical scaling, those which are good in terms of vertically scaling databases, MySQL and SQLite. Majority of the SQL-based databases, you will be able to find them vertically scalable. Okay. If we use combination of both, adding more CPU and increase them one by one, can we avoid downtime? So if you're changing the existing machine, it will involve downtime. If you're getting more if you're getting more machines, it does not need to involve downtime. Okay. What does the scaling limit depend on? Scaling limit. means how many resources I need to add or how much resources I need to add. It depends on what's the customer traffic that you have it. Okay. For example, you currently responding to 10K. Now you got a customer traffic for, let's say, 100K. So you're not going to build something for 100K. You're definitely going to build something for, let's say, 500K or maybe a million, right? Because you expect the traffic to grow. So that depends your what is going to be the expected scale. Majorly, it comes from the product requirements. Product requirements will very specifically tell what is the expected customer scale. And based upon whatever signals they get, market research, all of those things, they have huge amount of data behind that. And based upon that, you will implement it. Okay. One moment, Elasticsearch horizontal. Yes. At some point, we will force to do horizontal scaling. No, there's nothing called, okay. That speaking, yes, at one point, vertical scaling would be at the capacity, then you have to horizontally scale. Yes. Why different DBs are good at certain scaling? Good question. We'll answer that when we go to the database. I don't want to start a new chain of conversation now because it will definitely take more than 30 minutes, 40 minutes to explain. Okay. There's a reason behind everything. And the reason is how this data is categorized into it. When we go to databases, scalable SQL versus NoSQL databases, there we'll discuss more about it. Okay. All right. We talked about horizontal scaling. We talked about vertical scaling. There is third category I want to cover here as well. Scalability about database only. No, no. As I said, scalability is about server. Server can be anything. Server can be database server. Server can be application server. Okay. All right. Now let's talk about auto scaling. When we say auto scaling, we are referring only the part of horizontal scaling in it. What does that mean? That means combination of upscaling plus downscaling. What do you mean by upscaling and downscaling? You would have a configuration which will be definitely automated, right? It can be a YAML file or it can be a cron job, however you want to read it, implement it, up to you. Based upon your current consumption of memory, CPU, or RAM, let's say reach 80% of it. That's something that I was explaining. 80% for current instance. You can have that automated configuration or automated cron job. The moment it crosses 80%, the moment it reaches 80%, it will just spin up another instance. So you don't need to manually do it. Earlier, when this feature was not available, specifically the team, which we call as like platform team, in some company it is called the DevOps. The DevOps team slash the platform team, they were responsible to monitor it. They used to get like alarms and paginations about this. The moment they get pages about it, they used to spin up a new instance, right? All of those things pretty much now it is automated in all the companies. And if you're using any of the three cloud major providers, AWS, GCP, Azure, they have this already inbuilt in them, right? So you can write the configuration. The moment it crosses 80% of whatever number that threshold you want to decide, it will automatically roll up an instance. And obviously, all of these major providers or all of these providers in general, they go on a pay per basis, right? So if you get more instances, you will pay more, right? So on and so forth. Similarly, if your memory, CPU, RAM usage, let's say it reaches less than 40% or whatever number you want to decide for current instance, you can turn off that instance. Okay. So both upscaling and downscaling can be taken care as part of auto scaling. Okay. The part that I was talking about was pager duty or a pager. In different tech companies, developers are on call. For example, in fund companies, every developer is on call depending upon whatever their team size. In some other company, it is taken care by the DevOps team and so on and so forth. Okay. So depending upon what kind of organization, what kind of their operation excellence work, whether engineers are responsible for operation excellence or whether there's a specific team which is responsible for operation excellence, they will take care of that. Okay. And some good monitoring tools includes Kibana, Grafana, Dynatrace, etc., etc. Okay. There are some good monitoring tools that you can actually monitor your systems on. Okay. In a cloud, let me mention here also. You can have a trigger-based event, which you can consume via SQS or subscribe to a topic, whatever you want to. or you can just keep your app configuration for your feature flag, however you want to implement it. All right, let me answer a few questions here. Let me pause for a minute. Let me answer the question that I see in the chat. Database is already answered. How to make sure that system down doesn't interrupt running transaction? How to make sure that scaling down doesn't interrupt during transactions? Good question. See, that's what you need to decide the configuration. When it's giving 40% traffic, whether the 40% is customer traffic or it's a canary traffic. Canary is something which you run an integration test on or your own test traffic. Okay. Part one. Part two, can you redirect that traffic to some other instance while you are removing that or while you're turning off that instance? Okay. All those discussions, all those things that you need to take care of before turning off the instance. Because if it is still corresponding to 40% customer traffic, you cannot turn off that instance for sure. All right. New instance means running a new server, let's say an application server on the same machine, or get a new machine and start the instance there. Running a new server, let's say an application server on the same machine, or get a new machine. Running a new server. That's what we mean by horizontal scaling. If there are two instances and I've reached 80% of their capacity and so the instance is made which reaches only 30%, how can we turn off that instance? Wouldn't it be effect? Same question already answered. See, to avoid such kind of scenarios when one part or one particular instance at 80%, another instance at 30%, that's what the purpose of load balancer. Load balancer will equally try to distribute them. Okay, so avoid that scenario of 90 or 10 or 80 or 30. Automated downscaling won't be possible with vertical scaling. That is correct. See, that's why written auto scaling, it's horizontal scaling. Either upscaling or downscaling, we are only talking about horizontal scaling. Okay, cool. What is a cron job? A cron job is something which, well, you call as batch job, you call it a cron job. There are different terms to it. Something which runs an automated script. More or less, it's just an automated script which runs sequentially, right? It configs can be running every 24 hours, can be running every 48 hours, depending upon whatever time you want to run it. Cron job is something which is used to do a repetitive task. That's why you call the word cron job. Okay. All right, guys. This part clear to all? This part crystal clear to all? The first part, let me quickly revise. One moment. Horizontal scaling is one machine. Vertical is add more machines on that machine. It's the other way around. Horizontal machine, you're adding more machines. Vertical machine, in one machine, you're adding more and more CPU resources. Okay. All right. Coming to the first part, we'll keep a track here. First, coming back here, basics of system design is done. Scalability is done. Okay. I'll just put a break here. First thing first, we talked about scalability. We talked about what is scalability, capability of a system, network to grow and manage increased demands. What are the cases where you can have increased demands? We discuss three categories. How to solve it or how to scale it, there are two ways. We can horizontally scaling by adding more machines to it, or in the existing machine, we can add more resources to it. Okay, that is called vertical scaling. Then we talked about auto scaling as well, which is only in the applicable in the case of horizontal scaling, upscaling as well as downscaling. All right. Everybody clear with the first part called scaling. Scalability, if everybody asks, will you be comfortable enough, confident enough to explain that? Come on, guys, be quick. Okay. During upscale, downscale, will there be a short downtime? In horizontal scaling, no. We are just turning off the instances, right? Let's move on to next part, which is availability. Okay. Same thing. Before I give any answer or I give any update, I would open up to you guys based upon your understanding. No Google definition, no bookish definition, simple plain English. What do you understand by the term my system is available? What do you understand by that? What is availability of a system according to you? Whatever it is, just write in simple English downtime or simple English language. I'm giving you 30 seconds, guys, then I'll discuss. Take your time. All right, guys, as the time is up, let's see what answers we have got. Is app available in some error condition as well? Fallback scenario for error. How much time system is available to serve the request? Loading time is minimum in milliseconds. How much time it's operational for its user? Available everywhere on the globe. Okay. Responding as expected. Available to serve based on contract defined. Available 24 hours. Available of the service server at any time from anywhere. System level at time. Okay. Consistent availability of services and data. Is my app running? Available to everyone. Okay. Quite a very different answers. I believe all of you are trying to point to the same thing, but the answer is very different. Okay. One thing, just to clarify, I saw one of the answers admitting single point of failures. Okay. What has that do with availability? SPOF is a different concern. What is that has to do with availability? Okay. One thing to clarify before I move to availability, I saw one of the answer that it should be able to serve the response quickly or should be able to give the response in milliseconds. Does that fall under the umbrella of availability? How much time it takes for a request to give response? Does it qualify under availability? That is not. Okay. How much time it takes, turnaround time, whatever that is called the latency. Whatever latency should be, it's a completely separate thing. It has nothing to do with the availability. Availability means, in a very simple term, are you able to get the response? If a request comes, you're able to give response, that's it. That's what you call a system is available. Okay. I'll explain the real life example, then I'll give the definition and stuff. But just to clarify, how much time it takes to respond, that is what you call as latency, right? Throughput latency, whatever term you want to use here, or turnaround time. But availability is just, is it giving the response? That's it. So let's understand the real life example. That will make it much easier. Then I can explain about the definition. If I talk about WhatsApp, how will you define availability for WhatsApp, right? Availability is, if I send a message from my end, I should see a single tick. That's it. That is what you call as availability. If my internet is working, I'm able to connect to WhatsApp server. I send a message from my end. I see a single tick. That is what you call as availability. Okay. If receiver received a message and I see a double tick, it's availability. If receiver read the message provided with reader sets on, and I see a blue tick, that is what availability. That's it. Okay. That is what you call as availability. Simple. Second example, if you open any app and it is working as expected, that is when you call available. I open Zomato app, I am able to see the homepage service, means it is available. That's it. That's how simple availability is. If anything is available, means anything is working as expected, that is what you call as availability. How much time it is taking, that's a completely different concern. If it is not giving any time, if it is not even giving any response, that means say it is not available. Usually, if it gives you any 5fx code, means server is not available. It's give you 503, 502, 501, all of the 5fx code means it is not available. Just for telling you technically. This part clear with a real life example, what is availability? Come on guys, quick in the chat. No, 404 is a client side error. Anything which start with 4, which is a client side error. Okay. 5 is a server side error. 404 refers to the resource not found. So something that you're trying to find, it does not exist on the server end. Okay. That is nothing to do with available. 404 means server find the response, means server is responding you. Server try to find out the response. The response does not exist, right? Maybe it's a data which does not even exist at their end, or deleted data, whatever that thing is. That is what you call as, but still it is available, right? Because it's trying to search. So for your request, it is able to give the response. That is why still not qualified as a 5xx. Feature is not working, giving error, comes under availability. It might be due to bug. Yes. Anything which is with 5xx is server not available, or Not necessarily server not available, but it's on the server side error. Okay. All right. That's why you'll see all the 5 packets code 542, 543, 541. They'll start with internal server error. Okay. Cool. Now coming with the definition of availability. The definition is availability is the time a system remains operational to its request. Availability is the time a system remains operational to its request. Okay. How do we measure availability? It's measured in terms of 9. What do you mean I measure in terms of 9? Ideally speaking, a very good product would have 9 nines or 11 nines. What do you mean by 9 nines, 11 nines? How it is measured? If your system was not able to respond to 10 requests out of 100, you say my system is 90% available. 99% available means this is what we call as 2 nines. Just count the number of nines. That's what we call as availability. That's why it is measured in terms of 9. If I say my product is 99% available, means 1% of the request my server is not able to give response to. Okay. If I say 99.99999, this much percent, that is what you call as 7 nines. Okay. The closer you can get to 100, the closer you can get to 100% available, the better your product. Okay. Products like customer facing products like Facebook, Instagram, Google, WhatsApp, they have usually 11 nines. Okay. Of course, there can be downtime. No product is 100% available all the time. There can be downtime. But they have 11 lines, which is considered as a very good trademark or a very good hallmark if your product can reach up to 11 lines. The more closer you can get to 100, the more available your system is or the better your product is. Okay. Concept of availability, concept of measuring in line, understanding in real life example, crystal clear with all. I'll come to that. Concept of availability, concept of measuring in lines, and one moment, guys. Concept of real life example, clear to all. Okay, cool. Now let me answer the questions one by one. First question, how do we measure this? How do we measure this? Simple. Total number of requests, how many requests failed at the server end, not at the client end. Whatever the request, number of requests failed divided by number of requests into 100. That's how you measure it. Simple formula. Second question, 100% achievable in ideal world? Yes, it is achievable. If you don't have too much traffic, see, what will be the cases your system will not be available? There can be many cases, but most of the cases like, one moment, yes, this is called SLA. SLA can see SLA as a term is a very different meaning, right? SLA can be measured in terms of your success rate. SLA can be measured in terms of your timeline or latency, whatever that is. SLA is a very generic word. SLE for success, that's what we call as percentage wise. Okay. But what is the context that you're asking? Yes, that is what you refer as SLA. Okay. All right, 100% achievable part. Yes, it is achievable, provided you will take care of machines. They are all working. There is no possible way that your system might fail to a request. That is when it is achievable. Okay. In ideal world, yes. I just answered, right? How to measure it. Whatever is the number of failed requests divided by total number of requests into 100. Simple. You just want to check how many times your system was able to give response to. So you just subtract whatever time it is not able to give response to. That's it. Okay. All right, guys. Second part, availability. Everyone crystal clear? If the server is down, how will we know how many requests we received during the downtime? Good question. That is why the whole part of logging comes into the picture. Okay. During the time your server was not able to respond, you log every request before even going to server. It is definitely going to hit the application server before it go to DB server or web server before it go to the application server. You need to log each and every request which comes to your server, right? And then you have to log whether you give a response, successful response, unsuccessful response, whatever it was. That's why a whole part of logging and monitoring come into the picture. You'll monitor what request failed. You'll log what request failed. And based upon that, you'll get the count. Okay. Is there any real world tool that measures this, or we can write the manual script? Yeah, cloud services already log it depending upon how you're implementing it. For example, CloudWatch. Or one moment. Server is not the one logging it, guys. Okay, understand this. Understand the basics. There's a server. One moment, guys. Yes, web server allow logging. I put a CloudWatch log. Okay. That CloudWatch log or CloudTrail log, whatever kind of logging mechanism you want to have, totally up to you. OpenSearch, CloudTrail, CloudWatch. I'll just keep it here. OpenSearch, CloudTrail, all of this, whatever we do want to have. Everything that is going to the server, you integrated that with the log. So even if your server is not responding, you will see that in the log. Okay. On top of that, I should have said one more. On top of that, you will have the dashboards. This looks better. One moment, guys. Okay. On top of that, you will have the dashboard. So dashboard can include like Grafana, Kibana, Dynatrace, whatever you wanna. Okay. The first thing, you can definitely monitor in your dashboard what is happening. Then if you have to go down, you can check into the logging mechanism, and that is you will get to know what exactly is happening in the server. Okay. All right. Real world tool that measures this, so we get the manual script for this. Measures what's availability. Yeah. Everything is there in the cloud provider. Pretty much you don't have to do anything. You just need to use the right pretty much all the cloud providers have similar features. Any cloud provider that you're using, they will do it. Yeah, if you're running on call premise or on premises, in that case, you have to do some manual configuration. But more or less, we mostly have the cloud providers or we have the hybrid systems. Okay. All right. Everybody clear now? Any more questions on the availability part? Cool. Okay. If availability is good, there's a web server, for example, Apache Tomcat allows logging out of the box, just a text-based logs without CloudWatch or dashboards. Yes. Yes. In Tomcat, you can do the log files. Text or not, I'm not 100% sure. There can be format that you can convert it, but doesn't need to necessarily be text. Okay. ELK comes under monitoring. ELK not necessarily comes under monitoring, but it can be used for logging in general, but not monitoring process. See, monitoring, so when we say we refer about dashboards, right? Logging is also sub part of it, but monitoring we'll talk about mostly in the dashboard side. Okay. Done is here. You can give the full form in the chat while I start with this. Okay. Consistency. How is availability achieved? Okay. How is availability achieved? Make sure your server is capable enough to give the responses. Part one. Part two, your server is always running 24/7. Part two. Okay. See, understand in what case your server might become unavailable. Server can become unavailable. First, it has exhausted all the resources, means the request has become so large that your server has gone out of it. Okay. That is one case. So how do you solve that? You make your server scalable enough, right? Number two, in what else case, if your server does not have a backup, what do you mean by backup? In ideal world, not just in for any product, if it is a customer facing product, we do not have just one server. There's something called primary and there's something called secondary, right? Master slave kind of an architecture. So when one server goes down for some reason, whatever it is, before the scalability or anything in general, or in general, like system itself is not responding. In that case, we spin up so whatever traffic is coming on the primary will be routed to the secondary. So our system still remains available. Okay. Or whatever is happening on the master node will happen on the child nodes or the slave nodes, whatever you call it. So that is how you make sure our system is available. Have the right amount of traffic, keep your system open 24/7. That's how you keep your system available. Okay. All right, guys. This part clear? Long as be quick. This part clear? Okay. If this part is clear, we talked about two major concepts. One was scalability, one was availability. Now we're going to start with third major one, which is consistency. Consistency is also very, very important. Okay. Again, before I give my definition or before I tell you anything, whatever you understand by consistency in a system in simple plain English, let me know. 30 seconds for you. Whatever is your understanding, this is what consistency mean to you in a system. Let me know, then we'll discuss. 30 seconds on the clock, guys. Be quick. Oh, guys, I got only one response. Whatever you understand by consistency in a system, let me know. All right, guys, last 10 seconds. Last 10 seconds, be quick. All right, guys. Enough time. Let me go through your responses, then we'll come back to the consistency part. Let's see. Uniform, same response request all time, same response every time from anywhere. Output should be consistent, same request, same response always. Should be able to respond different table scenarios. Global irrespective of access devices. Okay. Same set of input in spite of where request was sent depends on system. Anybody else? Yeah, I liked one answer and I want to discuss on that because I never heard that answer before. So just want to know where that answer came from. But anyways, I'm just waiting for everyone to finish, then we'll discuss. All done? Cool. I saw one answer and I want to discuss like where did that part come into picture? Like where did you study about it or how did that thought come into picture? One of the answers said from all devices, it should come same response or irrespective devices, it should be same response. So give me a scenario and help me understand like where did you get this intuition first place? Give me a scenario where you got different response in different devices. For example, if I'm accessing on Mac, I'll get a different answer, let's say a website or app or anything in general, any kind of piece of software. And if I'm accessing on my Apple Watch or if I'm accessing on my iPhone, I'll get different answer. Give me one example of that. Recent example of Uber hiking price for iPhone, Android. Well, that is not consistency. Companies are aware of it and they are implementing it that way, right? It's nothing wrong. It's nothing wrong in the app per se. It's just that they purposefully know that people who are or who can afford iPhone, they should be charged higher and so on and so forth. So nothing wrong on the tech side of it. It's a business decision. It's a very well business decision. That's how the core logic is implemented there. You read the headers, and from based upon the headers, you get to know what kind of device you're using. Based upon device, you show the price, right? That's a very intentional thing that they have to do, which is bad. I'm not supporting it. But on the technical side, this is not wrong. You got a decision, you implemented the code that way, that's it. Okay. Give me example of this case, like you're getting different responses in different devices. Amazon app not working in tab. App not working in tab. If the tab is compatible enough, I'm pretty sure the app should work. Again, which tab, what model, all of this, that's something that I need to know before that. But if the tab is compatible enough, it should be working, right? Okay. Anything else? Cool. Site features may differ on mobile and websites. I mean, that is also again intentional, right? On mobile and website in the sense if it's a responsive website or non-responsive website, depending upon that, how they have developed. How far a system is corresponding with correct information, security reasons, and so forth. Okay. All right, guys. This was a new answer that I've ever got. So that's why I wanted to discuss on it. Why did it come in the first place? By the way, all the answers that you have given for consistency is incorrect. Okay. Why it is incorrect? One moment. Why it is incorrect? Because based upon your understanding, what you're referring to consistency is from a client perspective. I gave this request, I should receive this response, whether it is matching or not. You're thinking everything from the client perspective. When we are talking about in system design, we are speaking from the server's perspective, right? What is the definition of consistency in terms of server perspective? It means whenever there's an update in the system or in the server, all nodes, one moment, guys, all nodes are updated with latest information. This is something we call as consistency. If your server are updated, one moment, guys, let me confirm that. I'll give the examples. I'll give reasonable amount of examples. You'll understand it crystal clear. I'll make sure of that. Whenever there is update in the server, update in the data, update in anything, all the nodes which are responsible for giving decisions, they should be updated with the latest information. Okay, that is what you mean by consistency. Now, there can be two categories of consistency. It can be a strong consistency and it can be a eventual consistency. What do you mean by strong consistency and eventual consistency? Let's talk about it. Strong consistency means, as the name says, all the nodes would be updated at the same time. If every node is updated at the same time, even if there is milliseconds of non-availability. So even if my system is not able to give response for a few milliseconds, I'm completely fine. But I need to 100% make sure everything is giving the latest update. So there is no stale data. Whatever response I'll be getting from the server is the latest one. There is no stale data or the old data that I can give respond to. Even if I have to wait, I have to make the customers wait for a few milliseconds. Even if I have to increase the latency, completely fine. But first update it and then send the most updated information. Eventual consistency means, eventual, the word itself explains it, all nodes will eventually be consistent. Okay. When I say eventually, I'm not talking about hours and months. Eventually means few milliseconds. They can have stale data for very short time. which is again milliseconds we are referring here. So in milliseconds, you will see very old data as well, but it will be updated. But I cannot compromise on the availability. My system should be available. I cannot compromise on the availability. And you cannot have both consistency. We'll come to the cap theorem, we'll discuss more in detail. But in general, you will not be able to have consistency as well as availability. When I say consistency, strong consistency. You will not be able to have strong consistency and availability both in a distributed system. That's what the cap theorem technically speaks for, which we'll come to in some time. But anyways, this is what consistency is, types of strong and eventual consistency, and then I'll move to real life example to explain each and everything. But before I go, quickly revising, in a distributed system, yes, whatever we're talking about, we're talking in the context of distributed system, which by default includes partition tolerance. All right, let's first quickly revise it, then I'll move to the example. Consistency is whenever there is any update happening in the server, again, not from the client perspective, server perspective, any update happening in the server, all nodes will be updated with the latest information. That is what you call as consistency. Now, there can be two categories to it. First, strong consistency. Second, eventual consistency. Strong consistency means I want every single node in my system to be updated with the same data, right? The latest data. When I say same data, I'm referring to latest data. Until and unless in that time when all the nodes are getting updated, there might be requests coming. You will not respond to those requests. You will only respond to those requests once you got everything updated. So even for a few milliseconds, if my system goes down, even if it is not available, it's completely fine. Even if the transaction fails, customer tries, customer does not give a response, completely fine. But I cannot afford to show the stale data here. That is what you mean by strong consistency. Eventual consistency means my customer experience is most important here. Even if I'm showing some stale data, that is fine. It's not something so sensitive that they have to see the immediate data right now. They can see it later also. Again, when you say later, both cases we are talking about milliseconds gap, right? So even if I show them something after a millisecond, that is also completely fine. There's nothing wrong in that. But I don't want my customer to not get a response now. Okay. This definition clear, and then like use the examples, real life example, it will make crystal clear. But as of now, this definition clear. Come on, guys, quick in the chat. One moment, guys, one moment. I'll come to it. Okay. See, you cannot have consistency and availability together. That's what I'm saying. When I say consistency, you cannot have strong consistency. You can be eventually consistent. You can be eventually consistent and you can be available, but you cannot be strong, consistent, and available. Okay. Node is not referring to server. Node is referring to any parts of something which is given. It can refer to ports. It can refer to servers. It can refer to anything which is able to give the response. That's it. Okay. Now let's take an example to understand each one of them in detail. Okay. First thing, we'll start with the real life example. Everything will make crystal clear to you now. Take example of strong consistency, and even before I tell you whether it should be strong or eventually consistent, you guys will tell it. One node is down, the other is turning. See, but if a node is not available itself, the response will go to the other node, right? So that's it. Whatever node is not responding, we will not make it respond. If it's already down and this is the latest update, the expectation is not that whatever the down node, it will get up. That is not the expectation. Whatever the current active nodes, whenever there's a latest information pass, all of the nodes should be updated. That is the current expectation. As I said, node can refer to anything. Node can refer to server, node can refer to pods, node can refer to any pod, anything in general, anything which is responsible for giving response. That's it. Okay. All right. Now coming to strong consistency, let's try to understand an example. And you guys will tell me why it should be strong, consistent, or eventually consistent. Take a simple example. Let me remove this. I'll give you a real life use case. You guys are crystal clear with strong and eventual consistency. I'll show you what happens in both cases as well. As a customer and as a developer, you tell me whether it should be strong, consistent, or eventually consistent. That's it. First use case is food delivery service. Okay. Think of Zomato, Swiggy, Uber Eats, DoorDash, whatever it is. Okay. Understand the problem first, then give the answer, guys. One moment. Let me explain the problem first. On a home page, I'm talking about the home page service. There are two possibilities. Either it can be strong consistent or it can be eventually consistent. It cannot be both. Let's start with the eventually consistent. Since many of you are giving that answer, let's start with that. Now, understand. Eventual consistency means there is an update. What is the update that you will see on the homepage, first of all? The update would be which restaurant are open, which restaurant are not open. If it is eventually consistent, if it is, your homepage will immediately load. Your homepage will immediately load without any delay. Does it happen? As a customer, does it happen? If you have used this app, you would know the answer. But anyways, coming back to it, second part. Post. It will definitely be available immediately. Okay. Eventual consistency comes with the stale data. Means what? There are out of the homepage, whatever you're seeing, there is a restaurant. Time right now is, let's say, 6 o'clock. The restaurant is closed now. Okay. Since it is eventually consistent, it will show you those restaurants which are open, but they are closed. Okay. It is not immediately updated. Obviously, after a few seconds, milliseconds, whatever that is, it will get updated. This is what you would see if it was eventually consistent. If it was strong consistency, what would you see? Number one, there would be a delay when the app opens. Number two, there is no stale data. You would be exactly updated with latest information. One moment, guys. For all the restaurants, which are open, which are not, so on and so forth. Okay. Now tell me, as a customer and as a, one moment, guys, as a customer as well as a engineer, does it make more sense to keep strong consistency or does it make more sense to do eventual consistency for your customers? You guys tell me the answer. Okay. I'm still getting different answers. I was not expecting that. One more, if we cancel out, it will take time and eventual consistency. Feature has nothing to do with it. See, canceling of application or canceling order is just a feature. That has nothing to do with it. Understand, the update should happen at the server end. That's it. All right, guys, I got two different answers. One is eventual, one got consistent. Okay. As a customer, I'd expect strong, but as a system designer, I'll be preferring eventual consistency. Okay. Usage of the app. I explained the usage, right? I just explained the usage. This particular scenario, would you keep it strong, consistent, or eventually consistent? Okay. All right, guys. Now let's discuss the answer. I was not expecting two different answers. I don't expect two different answers. There's only going to be one answer. And one answer for this one is strong consistency, not eventual one. Okay. Now understand, for this use case, guys, I see a lot of people are referring to different use cases. Let's discuss, let's hold on that discussion for some seconds. We'll consider each and every example. We'll talk about strong consistency. We'll talk about multiple use cases. We'll talk about eventual consistency. We'll talk about multiple use cases. Okay. Let's first be crystal clear. What do you mean by strong and eventually consistent? Then you can pick up an example. Then we can discuss. Okay. I will make sure you guys are crystal clear to make a right decision, whether choosing strong versus eventually consistent. Just hold on to the discussion that you're happening right now. We'll go through that one by one. Focus on this one now. See, I have two things that I can take care of. One way is that if a particular restaurant, hotel, whatever that is, Delhi, if that got closed, I don't want my customer to be immediately updated. I can update in a bit later, but I don't want them to be immediately updated. That is what I'm referring in terms of eventual consistency. What will happen in that case is a customer can still see that order, a customer can still see that restaurant, they can still place the order, but they will place the order, then Zomato will call them, or whoever is the restaurant will call them, and they will say we are closed. Do you want that to happen to your customers? A customer will see hotel is open, customer will place the order, right? If I want to eat Matar Paneer, I'll place Matar Paneer, right? But the hotel will call me and say, hey, we are closed. That is a very bad customer experience. Do you want eventual consistency now? No. What will happen in the other case? Other case is also not bed of roses. There will be certain thing that you have to take care of, right? It is a trade-off that you will need to make. In this case, what will happen is customer will open the app. It will take some time, and in that some time, few milliseconds again. I'm not talking about hours and hours. In that few milliseconds, it will fetch all the latest information. Then it will show the current list of restaurants. It will tell you whichever is open to take a order right now. Now tell me, do you prefer strong consistency or do you prefer eventual consistency? Guys, why eventual again? As a customer, you would never want to order something which is not even available to order in the first place. It's like giving request to a server where you know the server will not be able to respond, right? So this use case is completely for strong consistency. Okay. Any kind of food delivery service, a complete use case for strong consistency. It's completely fine if a customer needs to wait for a few seconds till they can place the order slash till they can see the restaurants. But it's not a good idea. They see it immediately, they order it, later they get to know it's closed. Okay. So make them wait for a few seconds, few milliseconds, few seconds, but give them the updated data. So whatever order they do, there should not be any problems with that. Okay. Anyways, that is the correct reasoning behind it. Even if you did not know the answer, even if you have not thought through that much of reasoning, there was a very simple line that I have added. If you have used the application as a customer, one moment, guys. Even if you have used it as a customer, you would have clearly given the answer. Line number 379, line number 384. If you guys have used Zomato app, Swiggy app, any kind of app, have you ever noticed? If you have not all noticed, one moment, guys. If you have not noticed, open the app now, not right now, after the class. You will see whenever you open Zomato app, it shows you some food information slash vlogs. So it will tell you something like um, Italy has 52 type of pasta. Pasta was originally originated from this. French fries is not from the French. All of those things. Have you ever noticed? If you have used it, guys, you would know the answer. Anytime you open Zomato app, they will show you some kind of information. Have you ever wondered who asked for that information? Why are they showing me information? I don't want to know how many type of pasta are there. Why are they telling me? Think about it, guys. You're a customer and everything happens for a reason. Why are they showing you that information? What exactly are they doing when that spinner is loading and they're piecing that information? See, first thing, whenever that spinner is loading, nobody wants to see a UI which is a loading screen. That's why even if you have observed the UI screens now as compared to 10 years ago, you will not see that long circle of UI screening. And that's how Google Chrome has actually acquired the market from the Firefox. You don't want to see a UI where a spinner is loading. You don't want to waste time. And they need to fetch the data. So you cannot have both. While they're fetching the data, why not keep the customers engaged? So they would see they're getting some new information, but in the meantime, we'll fetch the latest data. That's exactly what they do. In meantime, while they are processing some food information slash vlogs or any kind of emojis or any kind of animations to you, they are fetching the latest data for the all the notes. That's what they're doing. As a customer itself, you can tell a lot about what kind of technical things are used. You don't need to be an engineer to know everything. As a customer itself, you can tell about a lot of things. Okay. All right, guys. Everybody clear with this? I've explained you the reasoning in detail. As a customer itself, if you don't even want to know the reasoning, you can still get out the answer for it. Everybody crystal clear with that. Okay. Now let me take a pause here before I move to second use case and answer some of the questions in the chat because I see there's a queue piling up. One moment, guys. All right, this is done. Okay, so many questions. I had to go one by one. Depends on time of delay. Takes a lot of time to bad experience. Delay is instant. Delay is always few milliseconds, as I said. Customer ever switch to Swiggy if Zomato is taking forever to open. Same will happen in the Swiggy also. Think hotel is open, place a order, then due to EC later disappeared or less lost. Long distance is good. Okay, already answered. Where am I? Eventual consistency after how much time not supported? Again, few milliseconds. In eventual case, what if I'm on a home page, I tried selecting a restaurant, then order selection menu and API may show it is closed. As soon as the user goes back, it might have the latest paper. It is possible, but think about it. That's a good use case. See, if let's say I'm keeping eventually consistent, assuming it's always going to be few milliseconds, what if the customer will go and the customer has not ordered yet, but at that moment we update that it is closed? Why do you want to do that? If a customer is already seeing the menus because customer wants to place the order, right? Customer would not see the menu if they don't want to place the order. I mean, there might be people who will be doing that, but in general, if a customer is there in the menu, customer wants to order. So why did you not update in before? Think as a customer, why did you not update before it is closed? Now I'm in the menu, I really like a dish, I want to order, but I cannot order because you did not update me in before, right? Think from the customer experience perspective. All right, this is good. Good, good, good. Anything else? How will they fetch latest information? Will take time to fetch. See, latest information, how they do it can be multiple ways, right? They have configuration written. Obviously, exceptional scenario, for example, a restaurant is always closing at 6 p.m., but now it got closed at 4 p.m. because of some conditions, right? Can be thousand other conditions the restaurant closes. That way has to be manual, right? They have to update Zomato that we cannot do it. That's when they will close on the app. Those are exceptional cases. But in general, they have a list of all these restaurants, what time they usually open up, what time they close, what time they're available to pick up, all of those things, they have it. Put them in a config file, update it on the app, that's it. Okay. Partition tolerance, we'll discuss more in cap theorem. Can a cron job keep doing it in background at least for home page so that the app will show data immediately? I won't say continuously, right? Because again, it will all depend upon whenever a customer will request for it. Scenarios like restaurant open, close, not accepting orders, will keep coming. Yeah, I already answered that part. Okay. All right. Cool, guys. Any more questions that I see? No, right? Okay. If the updation time is eventual constant millisecond, what's the difference? It should also work. I just explained, right? See, understand. If it is milliseconds, why it is not a good idea? Understand this. If you show me a restaurant, let's say this is my favorite restaurant, you know already at this moment it is closed, right? But to save few milliseconds, it might be seconds, doesn't always milliseconds, few milliseconds slash seconds, right? Whatever the time is. Why would you not tell me in advance? Why you are showing me that it is available to take an order? I will go to its menu. In that few milliseconds slash second, customer can place an order. Or even if it is not placing an order, they will definitely look at the restaurant. They will look at the menu. So why not to tell them in advance? If you already know at this moment of time, at this timestamp, that the restaurant is closed, just update them it is closed. Why are you giving them an option to look at the menu, place an order, and then have a bad customer experience in the first place, right? And if you have noticed carefully, they tell you that restaurant is about to close. If you have not seen it, say it again whenever you use the next time Zomato. They tell you the restaurant is closing in 10 minutes, 20 minutes. You have this much time to order or this much time to place an order. If you have not observe it carefully because it's always a good customer. How are they getting that data? They're getting the data from the configuration file they have, right? Yeah, whatever time. See, in their config, they know the restaurant places at 10 p.m., right? So if it is 9:50 p.m., they will show you you have 9 minutes, 59 seconds left, and so on and so forth. That's how they're doing it. Okay. All right, guys. First example, millisecond update will be done after a trigger or a cron job. Yes. Once they receive the latest information, obviously there would be a cron job running, which will be updating it, right? All right, guys. First example, crystal clear to all. Example of strong consistency. Okay. We have 10 minutes. I want to take one more use case. You guys will tell me whether it is strong consistency or eventual consistency. Okay. Once app is opened, there is chance that restaurant details will update, not closing time. Once app is opened, there is a chance that restaurant details will update. Yes, such scenarios can happen, right? For example, a new dish is added or the restaurant got closed or anything in general. That has to be a manual process. Restaurant will need to reach out to Zomato, they need to update, right? They cannot immediately update it. So those scenarios will exception scenarios, right? All right, cool. Let's start with the second use case. You guys will tell me whether it needs to be strong consistent or eventually consistent. But before I go to second, any more questions on the first one? Everybody is crystal clear on the first one. Why this food delivery service need to be a strongly consistent app? Come on, guys, quick in the chat. Okay. If everything is good, now moving to the second use case. Second use case is cab service. Think of Uber, think of Lyft. I don't think there's any Lyft in India. Think of Grab, think of Ola, etc. etc. Okay. So a ride finding service means search for nearby drivers. What do you think? Strong consistency or eventually consistent? Think about it, guys. Think from a customer experience, it will tell you the answer. One guys, be quick. Do you want to search for the stale drivers? Do you want to search for the all drivers, all data? No, you don't want to. The use case is I need the latest data. If I'm booking a cab, I want to know the latest data. Some delay in finding that is fine. In case you're connecting with me a driver, that is fine, right? This has to be strong consistency. All the cab service application, they have to be strong consistent. Why they has to be strong consistent? Whenever you try to open a Uber app, again you will notice a microseconds of delay in the home page. Then when you try to book and connect with the driver, definitely there's a delay, right? It finds the driver, connect with it, all of that. But before that, it fetches all the latest information of the driver, whoever are closest to you. And then it will show you about the expected time of arrival and so on and so forth. Okay. Again, a very crystal clear use case of data being needs to be strongly consistent. Everyone clear? We'll come to it, guys. We'll come to it. Let's discuss the crystal clear example of strong and eventual consistency. Then we can take other examples. Okay. First use case, food delivery. Second use case, cab service. Are we good to move to third use case? Third use case, you guys tell me whether it's a strong consistent or eventually consistent. Social media application. Let's say Instagram, Facebook, anything. If I talk about Instagram in general, you guys can tell me answer, then I'll talk about it. This concern also mix up for different features inside application. There might be features in app or can be yes, yes, yes. It can be combination of see one feature can be eventually consistent, one feature can be strong consistent. Yes. Okay. All right. Cool. Let's understand now. First thing first, when I say Instagram, I'm not talking about product. I'm talking about specific feature of homepage. So if I go about homepage, which I'm talking about homepage service slash newsfeed. Do I want to see the latest data in the newsfeed, or do I want to immediately see the newsfeed? What is the requirement of a customer here? Think logically. When people open Instagram, do they want to see the latest update first? No, they just want to see Instagram first, whatever it is, right? So what is the priority given? Priority is given that your Instagram or whatever social media app should be up and available. Okay. Here, my availability will prevail over consistency. What do you mean by prevail over consistency? Let's say you have a friend or you have a follower, whatever you call it. I mean, you are following them. In that, when you are following, if somebody has, one of your friend has posted something, you immediately do not see it. But over a period of time, you are going to see it. Eventually, you will see the updated post. Even if you're seeing the stale data or old post for the time being, it's completely okay. It's completely fine. But what is not fine is making the customer wait just to show them the latest data. Nobody wants to open Instagram, wait for a few seconds till they see the most latest update. They're not interested in latest update. If people have used social media, they have come there for passing their time, right? They're not looking for something immediate update. So there's no point of making the customers wait for it. You show them the data, whatever they have, and while you can do it, you can update it. That's why you would see while you are scrolling feed of Instagram, it will automatically refresh sometimes. Have you noticed that? When you open Instagram, it might show you feed from 3 days ago, 4 days ago, 10 days ago, whatever time you have last login. And while you are scrolling, it will suddenly refresh it. Why suddenly refresh it? Now it is pushing the new data for you to see. Okay. But delay is not expected here because if you start putting delay in a social media application, people will not use it. And the whole point of a social media application is to increase the engagement. So this is a crystal clear case of eventual consistency. Okay. All right, guys. Now let me take a pause again, quickly answer some of the questions in the chat, and then we'll quickly revise the session today. Answer this. Consistency already answered that. This is done. I don't want to miss out on any post my friends posted 4 hours ago. You will see it eventually. You just not need to see it immediately. For cab services, user can see the incorrect nearby drives. At last, driver has to be accepted the ride, not the users. If they are available, they will not accept the ride. So it should be eventually consistent. No, no. Okay, understand. I'm talking from a customer perspective here, right? What do you mean by strong constant? And even from the server perspective as well. You need to show the update status of the nearby drivers, right? If you don't show the update status of nearby drivers, customer would get a wrong idea of what's the ETA for them. Okay. So that's why when you put a destination, when you put a source and destination, it takes some time. Whatever that milliseconds of time, it's trying to find out what are the nearby latest drivers. That is why it gives you 10 minutes away, 8 minutes away, 7 minutes away, kind of a thing before you even book it actually. Okay. All right, guys. I think this is good. Any more questions on third use case? If we are good, let's quickly move into revision. Strong consistency availability cannot be together, CAP theorem. We'll discuss it about in the next class. Okay. There is one database which defies CAP theorem. Well, it's a workaround why it defies CAP theorem. If you want to read in more detail, I can discuss that. But technically speaking, CAP theorem will still hold valid for everything. All right. Consistency part is done. Now we are at load balancing where we need to start. All right, guys, we are right on time. Let's quickly revise what I've discussed as part of today's session. Then I'll come back to the feedback that I discussed, right? First thing first, it's a very first session of our high-level design code, so it's good to know about each other. So I get a brief idea of about what kind of audience I'm actually teaching for. You got an idea about who is your instructor, so on and so forth. Okay. We start with the system design. First thing first, we talked about what is system design. It's a software system interacting with different components. What do you mean by components? Load balancers, client server, DB caches, web server, application server. These are components. Design usually refers to two categories. It can be a high-level design, it can be low-level design. High-level design talk about overview of different components of system, DB schema, what choice of API, what sort of connections, what choice of load balancers, how many servers, and all of these numbers. What's the expected scale? How many servers would you need? What's the year of storage? What kind of database or what different categories of database you will need, so on and so forth. Lower level design talks more in terms of implementation of code. For example, design principles, best practices, design patterns, machine coding around CML diagrams, etc. etc. Okay. Where does it fit in the case of software development lifecycle? It fits in the solution or design phase, where we talked about high level first. Once high level design is done, then we move to the coding implementation. Okay. We start with the high level design here, key characteristics of a distributed system. So we start with number one, which is scalability. We define what is scalability, capability of a network so it can grow and manage the increasing demands. We talked about what's the reason to scale, what can be the possible reason for increased demands. We talked about what are the ways to scale in terms of horizontal scaling by adding more and more servers into pool of resources, and vertical scaling by just adding more computational power to the existing machine. Okay. Then we talked about auto scaling, which is horizontal scaling, which is done by upscaling plus downscaling, ideally keeping by YAML file or a cron job. Okay. Then we move to second category, which is availability. Availability means how many percentage, how much time a system is available or operational to the request. We measure it in terms of nines. So 11 nines or 799s are usually considered to be very good available system. Okay. We talked about the real life example of what do you mean by availability. Okay. Then finally, we talked about consistency, another important thing. Consistency means whenever there is update in the server slash system, all nodes should be updated with the latest information. Okay. Now there can be two kind of consistency. Strong consistency means first update all the node with the latest data, then respond to any request, which will definitely involve some kind of either failures or some kind of downtime whenever you're giving any response. System would become non-available for some time. Second, eventual consistency means I don't want my system to become non-available. So even if some node has all data, let it respond with the old data, then whatever is updated, obviously in the meantime, it will be updated, then give the updated data. Okay. So we talked about examples. For example, for food delivery use case, it has to be strongly consistent. I explained why. For cab service, it has to be strongly consistent. We discussed why. And finally, for social media application, it can be eventually, which is eventually consistent, and explain the reason why as well. Okay. All right, guys. That being said, that is something that we discuss as part of first class. First, let me know if everybody is crystal clear with everything that I've taught in today's session. Any doubt, any questions, please let me know. Okay, everything is good. That's part one. Part two, is the speed good? Do you want me to increase it? Do you want me to decrease it? Is it too slow for someone? Is it too fast for someone? Let me know. Okay, this is the regular class timings. I think yes. Yeah. How are the assignments before the HLD and LLD? I can speak for the HLD right now because that's what HLD is going on. So you'll get the assignments from your course coordinator, and according to that, there would be someone to review. Okay. Apart from your session, where can we read about the topics? I would say just refer to these topics. In general, I will anyways cover it. Where to read? If you're asking about the resources, I'll share in the next class. What are some good resources for high level design? Okay. Can you take more example for strong? Yeah, I will continue with more examples. Diagrammatic explanations, yes, we'll move to diagrams when we go to the case studies. Okay, and we'll use diagram wherever required. So don't worry about high level design is all about the diagrams. Okay. Cool, guys. Capture them in next class. Yes. All guys, any more questions? All good? Cool. Thank you for yes, fine. If everything is good, let's wrap up the session here for today. Let's catch up in the next session, then we'll come for it. Okay. Yeah, we'll discuss that CD and stuff. Okay. All right, guys, thanks for joining in and have a good weekend. Let's close up for today and we'll connect in the next session. We'll resume from there. Thanks for joining in and have a good one.